Vector 2. Discrete time signal transformation.
Hello guys, so we are continuing a new video. So recollect, its input we are giving this. This is the circuit. Vt equal to RIT. So L into divided by Vt is the equation, and we are giving as I of t as output for the signal. This is the input. So this is the input. We are giving x of n as the input, and y of n equal to 0.4 y n minus 1 plus x of n, and we are getting the output as y of n. So standard control continuous time signal. Standard discrete time signal when input of the output of system. When the unit step signal u of t equal to taking 1 and 0, t will be greater than 0 and t will be less than 0 over here. And here, just drawing the diagram, and this is the straight line we are getting for this graph. And this is a dt direct time unit step signal u1. un same 1 and 0, n greater than equal to 0 or n less than equal to 0. We are getting this plotting continuous impulse function. We are getting infinity to minus infinity dz. So the discrete impulse function same appears here 1 to 0, but here n should be greater than 0 and n equal to 0. So the exponent signal straight line over here. This is the plot. So this is the plot, real-time exponent signal. The x of n is not defined for the values between the integers. Transformation of interval reflection we are getting. Let x of t be the exact function. So we are getting example, we are taking x of t equal to e raised to minus 5 u of t x of 0 0 over t of 0. So we are taking the graph of is minus 5 5 0 5 5 0. So time scaling, that x of be the function of scaling t equal to a of t. Example, we are taking this from here x of t of 2, where so for t is x1 of t and x of t by 2. This is for the x of t equal to x of 2t. This is the tabular column. We are representing the plot from -1 to 0.5 and 0, 0.5, 1. And we are plotting, it will be time shift property. The time shifting x of t equal to x of t minus t naught. T we are taking from here. So x1 of t we are taking. So the -1, 0, minus 0, 1.5, 2, 2.5, 3, 3.5. X of -3, x of -2, x of -1, x of minus 0.5, x of 0, x of plus 0.5, 1, x of 1.5. So x1 of t will be x t plus 2. So z z of -3, -2, -1, 0, 1. F of t x1 of -2, x1 of -1, x1 of 0, x1 of 1, x1 of -1, x1 of 0, x of 1, x of x of 2, x of 3. X of t minus t naught. So t minus t naught is equal to -2. This is the plotting of the graph. -3, it will become -1. So given x of t, we can take from find x of alpha t plus beta. First method is time shifting x of t plus beta. T equal to t plus beta. So time shifting alpha t plus beta. The second method is time scaling. Where x of t is scaling, we are taking 2t. X of alpha plus t minus t. Alpha plus t plus beta by alpha. X of alpha t plus beta.